I'm going to do page 28, number 4. So we have 4, yeah, it's okay. 4x4 minus 5x squared minus 9.
Divide by x?
No, not that first. We want to solve this. Now, I give you a little hint in the question. I say in the question, let u equals x squared. Therefore, u squared equals x4. So if you square both sides, you'll get this. So that means my original can be rewritten as 4u squared minus 5u squared minus 9. Oh, sorry, I wrote square twice, didn't I? Just, yeah. Minus 9 equals 0. Okay, so this has two answers. Does it have factors? Yeah. Is it going to be, well, it's going to be 3 and 3, is it? Let's see.
4x minus 9?
It's a 4u minus, and then it'd be 1u there, and this would need to be a plus.
Plus 1.
And we need a 9. Yeah, 9 here, and a 1 here. Yeah, that'll do it. Okay. So we got two answers here. U equals 9 over 4, or u equals minus 1. Now, we have to remember that u equals x squared. So we get x squared equals 9 over 4, or x squared equals minus 1. But you realize that this one here doesn't make sense because x squared can't be minus 1. Yeah, so we have to reject this one here.
X equals I.
Yeah, so we just stick with this one. We get x equals plus or minus the square root of 9 over 4. So that means x equals plus or minus 3 over 2.
Are we going to have the complex numbers?
No.
No, like never, or no second year?
Never. For us.
Not in foundation year.
No.
Yes. Well, not in maths. It's in further maths.
You'll be having it next year.
Yeah, of course I will.
I won't be.
Yeah. You'll just have people throwing up and getting sick on you. So much better. Okay. Any other questions? Yeah, you just think about that now. Any other questions? No? I think that exercise is, it's kind of easy. You just have to use the formula for every question, really. So I don't think there should have been any complicated. Joseph.
Yes. Not you.
Joseph.
He's Joshua.
Sorry. Apologies. Joshua. You're giving me trouble again in maths class. So I'd like you to sit up the front here. No? Yeah. Move up the front there. Hurry up. I'm not going to talk while you're walking, so get moving. All right. So if you, while we're waiting, turn to page 30. Go there. Got over there. Wait, where's your maths book? So you're causing trouble and you left your maths book at home. You're sharing it with who? You can borrow my one when you need to do the questions. Get up the front. Okay. Now, page 30. Can I scroll down? Do you have that now? Yep. Okay. So if we go back to our formula from yesterday, we have, if you remember, x equals minus b plus minus square root b squared minus 4ac all over 2a. And I highlighted that piece in blue because that piece is very important. Because if this piece is negative, then we have no answer here. Because if we try to type this in on the calculator, it doesn't work. We cannot have the square root of a negative number. So when this is negative, we actually have no roots. No answers. When it is 0, we have one answer only because if you think about it, you would end up here with plus or minus square root 0. And what's square root 0? Yeah, and plus and minus 0 are the same, aren't they? So if it was 0, you have only one root. And then finally is the case we prefer is when it's positive. And then it has two roots. So you can know how many solutions you will have by just looking at this piece here of the equation, of the formula. So this piece is given a special name. We call it the discriminant, which is the name of the lesson, and the symbol we use is the delta symbol. Yes, the same.
What's the difference between roots and vertex?
Roots is where it crosses the x-axis, whereas vertex is the minimum point or maximum. Now, vertex is usually not an intercept. It's just the lowest or highest point on the graph. Roots are the x-intercepts, yeah.
Can we use instead of delta the big G?
Yeah, that's what I used to use. But a lot of my students tell me that they use delta in high school. But in Ireland, we use capital D.
Like normal people.
Yeah. Normal people.
I said like normal people.
Yes, I won't disagree with you. Okay, I'm too polite to disagree. Right, okay, so let's have a look at some examples of what this means. Okay? If we just take the first one as an example, 1a. Now this table is important here. So I'll give you a minute. You need to write this down for sure. Okay, can I scroll down now? Yeah, okay. So if we take 1a as an example, I ask you how many roots does this quadratic have? Now please listen, I do not want the roots, I just want to know how many roots. So I calculate my discriminant. Oh yeah, be careful. I'm saying discriminant. Don't confuse that with determinant. Okay, this is discriminant. Okay. Here, this is b squared minus 4ac. That is 9 minus 4 times a times c. Now that looks like it'll be negative because, yeah, you get 9 minus, what is it, 100 and... Yeah, well, whatever it is, it's definitely negative. So this actually has no roots. So that means if I was to draw it, it would be like this. It doesn't cross the x-axis. What's this value here? What's the y-intercept? Yes, minus 6. So no roots here. Okay. Let's have a look at a more difficult one now. So let's look at 2a. Well, actually, you know what? Let me just make sure you got the idea here. Try b for me. Tell me how many roots b has. So I want to know the number of roots here. Hey, do you need to talk to me or to all of them? Huh? Oh yeah, no. Yeah. No, I had them last week, I think. So they should have exam prep, and I should have the business students tomorrow for ICT.
Right, okay.
Yes.
I saw this new student called Charles, realised that I gave him the wrong time to he's going home. Anyway,
Okay.
You'll see him tomorrow.
Oh, redirect them.
Yeah.
No
And
problem.
I'll give him a new time.
Sure.
Okay.
Grand.
I need to let somebody to take them on a tour
Okay.
when he's around.
I'm gonna. This is a double class, so I'll give them a break in the middle if you need to talk to anyone or anything like that. Yeah. Okay. Do you have the answer here now? 2 roots. Very good. So the discriminant is positive, so it has 2 roots. Okay. So let's move on to more difficult. Oh yes. Again, hand not matching words. Positive. Okay. Let's look at one that's more difficult now. 2a. How many roots does this have?
-1.
That's a K. Deal with it.
Shades.
If either 1 or
Forgot the shades.
1 or 0.
Here you go, Hussein. Okay. There now. Four. Okay. Right. Clearer? Okay. That's how I roll. Okay. This one is different because you don't actually know the ABC. The ABC has this K in it, which you don't know.
You know the signs?
You know the signs, but you don't even know if K is positive or negative. We could take it out there, but it's we can't do that for all of the questions. It's not possible. So I won't do that here, but you're right, we could. I won't for this one, though. The only thing I know about K is that it's not 0. Why is that? Yep, that's true. And another reason too. Yeah, well, it's not 0 because if the K was 0 in the front, it wouldn't be a quadratic. It'd be linear. And in fact, as you said, if the K was 0, it'd all be 0 anyways. Okay, so all I know is K is not 0. But we can still find out how many roots there are. So that's interesting if you think about it. I cannot find the answer because I don't know what the K is for my formula. But I can still find out how many answers there are, even though I cannot find the answers. So if I look at that, delta equals minus 4k squared. I'm going to go back to doing k properly, okay? Minus 4k squared. So that's b squared minus 4ac. So that would be 16k squared minus 16k squared, which in this case is 0. So, yeah? No? 1 root. So I cannot find the root, but I know that there is only 1 root. So that means no matter what the value of k, except 0, this will have only 1 answer. An answer which I don't know.
How did you know that's only 1 root?
Because this is equal 0. Yes?
So it's like better like that.
Yes, so on the graph, if it has only 1 root, it looks like this. Or, well, in this case, well, I don't actually know if that's positive or negative. It could be upside down, yeah. But the problem is...
No, I mean, can it be like, not like this? Yeah.
No. No. No, not in this case, no. I'll do another example of this since it's more difficult. I'll do 2b. You need a minute to write this down, yeah? No? Okay, 2b. minus k x squared plus minus k plus 9x plus 3. Again, I cannot find the roots, but I can actually work out how many roots there are. So delta discriminant is b squared minus 4ac. So that is k squared minus 18k plus 81 plus 12k. Sorry, it's okay. Which equals k squared plus, not 12, it's plus, minus 6k. Minus 6k plus 81. Now, here what you need to do is look at this not in this form, but instead in this form. What's 81 minus, what's 81 minus 36, please?
45.
What is it?
45.
45, okay. All right. Minus 9?
Now you can solve this.
Wait. Minus 9, where? Oh, sorry, but it's still positive, isn't it? What's the number? Wait.
72.
Okay. Thank you. 72. Okay.
What?
How did you get this?
I'll complete the square here.
Oh, okay.
So could you explain
Yeah, what I'm going to do now. So, up the very top is my original quadratic, and then underneath I calculate the discriminant. Okay? So that's the discriminant, and then that's it expanded, and then that's it there. And for the last line I completed the square. So this here is my discriminant. Is that positive, negative, or 0? Positive. So if it's positive, how many roots? 2.
In this one, in the second quadratic that you get?
That quadratic there is positive.
Yeah.
And this quadratic, positive. And what does this quadratic represent? Discriminant. So this discriminant is positive. It means 2 roots in the original.
But discriminant in the second quadratic is squared minus 6x plus 81 is less than 0.
Yeah?
So it's less than 0.
No. This number here, positive or negative?
Positive.
Positive. This number?
Positive.
Positive.
Okay, I misunderstood what you
Yes.
meant. Okay.
So this is total positive. So my discriminant is positive, which means my original quadratic has
2
2 roots. Okay? Yes?
what if there was negative 7? What?
Then you don't know if it's positive, negative, or 0. It could still be anything. Yeah? Now, just to make this point clear, remember k cannot be what value? 0. So if you take k as 1, for example, and you were to take k as 2, and you were to take k as 3, and you were to work out how many roots this has, everybody will get the same answer. Should be 2. So I know that this will have 2 roots always, even though I don't know what k is.
Can we just replace the k?
No, because the question is wanting you to prove or to show, it has 2 roots. Now, if you did replace the k, you would still get the same answer, 2 roots. But you wouldn't know if that was always true for all the values of k, just for the one you picked. But I know, no matter what value of k I choose, except 0, because of the square, this discriminant is always positive, which means it always has 2 roots. Okay? And what you're trying to learn from this lesson is that it's sometimes possible to know that there is an answer and not know what the answer is. So I have proved that this quadratic has 2 answers and I'm not able to find them. Say that again? Yeah, well, then It was like my last example where the discriminant was 0.
No, x equals 1 twice.
Yeah, that's one root. It's the same one twice. That's right. Equal roots is the same as one root. Yes?
Is there a way to find the two answers?
Impossible. Impossible. I can just tell you that there are two. Let's have a look at another example like this, but this one's important. So, did you write this down? Yeah, okay. So let's take, for example, which one do I want to do? Yeah, let's say G, because it has two brackets in it. 2G. So you have minus kx squared plus minus 3k minus 4x plus minus 2k minus 5. So let's see how many roots this has. B squared minus 4ac. Okay, so this will be 9k squared plus 24k plus 16, and then I have to open this, so this will be negative, 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 which is negative 8k squared, and then 4 by k by minus 5, so again negative 20k. So when I open the brackets, when I expand, I'm left with this, which simplifies to k squared plus 4k plus 16, which will equal k plus 2 squared plus 12.
So it's minus 14.
Oh, again with the minus. Sorry. Here should be minus. Yes, it's disgrace. Minus here, which means here it is a minus.
No, it's 24 minus 20. It was plus. It's alright. It's plus.
It's not plus 14.
Plus 4k. It's okay. It happens. Alright. So in this case, the discriminant is
Positive.
positive. So it has, again, two roots. Next example now. So anyways, it's still the same formula. We're just using b squared minus 4ac. Yeah. It has two roots. Hey, are you asking why it has two roots?
No,
Is he asking?
I don't understand the discriminant of
The last step, is it? Yeah. If the discriminant is positive, it has two roots. Remember the box I gave you at the start?
Yeah.
If it's positive, it has two roots.
Zeros,
0, one root,
yeah.
one root. Negative.
But it can be, k can't be equal to 0, yeah?
Yeah, but don't worry about that. That's not important. What is important is this number is positive. This number is positive. Positive plus positive, positive. So discriminant equals a positive number.
Yeah.
So
two rows.
two roots. Yeah.
Also with this.
Okay. This is okay. Yes. It's very, very similar to the exercise on completing the square. In fact, because you have to use that at the end here. Yeah. If this comes up in the exam, they'll probably make it a little bit easier for you. If this comes up in the exam, what usually happens is you don't actually have a piece here. It usually cancels. So on this line, you would get k squared plus 16. So it's easier to see it's positive. I can only see it's positive if I complete the square. But I'm saying in the exam, probably this piece won't be here. So you can see it on this line instead of this line. Okay? So that makes it 1, 2, 3 marks. Whereas if I include this, that should be 4 marks. Okay. Alright, the next one now. So this time is backwards. Here, I don't know k, and I want to know how many roots there are. In number 3, I know how many roots there are, and I want k. So it's the reverse. So I'll do 3a as an example. So I tell you, minus k plus 4x squared plus 2k minus 2x plus minus k minus 1, has only one root. No, in this case, you're told it and you need to find k.
So the discriminant equals to 0. Yeah?
Very good. Discriminant equals 0. So that means b squared minus 4ac needs to equal 0. So you get 4k squared minus 8k plus 4 minus 4 brackets. So now we'll multiply these two together. K squared minus, hang on, that's minus 4k and that's plus k. Minus 3k, is it? Minus 4 equals 0. So then I get 4k squared minus 4k plus k. Yeah. 4k squared minus 8k plus 4 minus 4k squared plus 12k plus 16 equals 0. So that's nice because that cancels that, so that's great. So here we get 12k minus 8k, which is 4k, and then 16 plus 4 is 20, so that's minus 20 on the right. So is that all accounted for? Yeah. So k equals minus 5.
Is that what is about k?
Say again?
Is that
12? This is a 12.
yeah.
Yeah, k.
Next to k.
12k. No power. So k must be minus 5 for this to have one root.
K must be minus 5.
Yeah, there's no choice. If you want the discriminant to be 0, it's only if k is minus 5, and no other value would make it 0.
We can check that question, right?
You're right. Very good. You can put the minus 5 back in and see if this quadratic has only one root. Yeah.
Basically, expand and then
Expand, group together, and solve. Yeah. The tricky thing here is just being careful with your multiplying when you expand. That's all. So we expand, group together, and solve for k. It's just something you have to be careful with, that's all. Okay. That was an example when you have one root, the discriminant is 0. But let's look at an example where maybe you have 2 roots, so the discriminant is positive. So that would be D here. 3D. Okay. Can I scroll down? Yeah. Okay. So 3D. Minus 9k minus 9x squared plus 6k plus 6 minus k. Minus 9, 6 and 6 and minus k. And this has 2 roots. So, if it has 2 roots, we know that discriminant should be positive. So again, b squared minus 4ac should be positive. So here I get 36k squared plus 72k plus 36 minus 36k. Is that right? 4 by 9 is 36, and minus, minus, and a minus. And then minus 4 and minus k, another minus. Sorry, that's k squared, 36k, greater than 0. So again, Hussein, I'm just expanding here the brackets, that's all. You have to be very, very careful because there's lots of minus signs here. But the same thing has happened. Here, this one cancels this one here. So you're left with 72, so 36k plus 36 needs to be bigger than 0. 72k minus 36k is 36k, and 36 is 36. So then 36k must be bigger than minus 36. So k must be bigger than minus 1. So in this example, for this quadratic to have 2 roots, it must be that k is more than minus 1. So I can't know the value of k, but I can know it must be more than minus 1. And that's all I can know. And I want to graph this one here.
Can it be 0?
K could be,
Yeah.
oh yeah, and k could be 0, but k cannot be minus 1.
It has to be bigger.
Now, why can k not be minus 1? Well, it can't be because I say it's bigger than minus 1. But there's another reason k can't be minus 1.
Because of the numbers.
No. Yeah, 1 plus. No.
Because if it would be minus 1, then the coefficient of x
Yeah.
squared would be 0.
If
It's not a quadratic.
k was minus 1, then you see the number at the front, the minus 9k minus 9?
Yeah.
That would be 0. And then it wouldn't be a quadratic. Yeah. Right here you go. Yes.
K was 0.
K could be 0, yeah. If k was 0, what quadratic would you have? Minus 9 x squared. Oh, sorry, I forgot to write my x. Plus 6x minus 0. Yeah. K could be 0.
It would be, it would have one root.
No, it would have 2. Why don't you check it out? If k was 0, what quadratic did we say we would have? Minus 9x squared plus 6x minus 0. So check, how many roots has that got? Well, what's b squared? 36. And what's 4ac? 0. 36 minus 0? 36, which is positive, which is 2 roots. Okay, so this, if it's to have 2 roots, k must be more than minus 1. I have seen this in the exam a few times, okay? A few times. And again, you see here, this cancelled this. You see that? That happened because I made the question that way. I made the question so that they would cancel, to make it easier. Okay?
They do.
And in the exam also, I think they would do it too. That if this question came up in the exam, I think the same thing should happen to make it easier for the student, because this is not difficult to solve. You just bring the 36 over and then you divide by 36. But I just want you to know that that cancelling doesn't always happen. It only happens because I made the question that way. But it's not supposed to happen. It's not like, you remember with the conjugates, with the surds, when you divide, you multiply the top and the bottom by the conjugate. And what's the reason for doing that? To cancel the root in the denominator. That's supposed to happen. That's not supposed to happen. It's only because I made the question that way. And it's important that you know that. Okay? And in the exam, I think they will do the same thing. Okay? Now, I want to talk a little bit more about this example. So, did you write this down? Yeah. So, I want to graph this example to show you the different graphs. Okay. Focus. So what I'm going to do is I'm going to draw different graphs for different values of k, and you can see how the number of roots change. Okay. Right, can you read out, please, the equation? What is it? Y equals minus, what's it? Oh, it's not there. Read out the original question. What's the minus 9k, was it? Or?
Yeah.
Yeah.
Minus 9k minus 9.
Hang on. Minus 9k minus 9x squared.
Yeah.
Yeah.
Plus 6k plus 6.
Bracket.
Yeah. Bracket.
6k plus 6
Minus
x
x.
minus k. Now, I can't draw this because there's no value for k. So what I'll do is I'll put in a value for k. Let's put k is equal to 3. All right, how many roots should this have? Should have 2. So let's have a look at that. It has 2 roots, doesn't it? Now, let's put in a different value of k. So if I put k is 0, how many roots? 2. See, it still has 2. Now, what happens if I put k is minus 3? Well, it shouldn't have 2 roots anymore, because what did we say k needs to be more than? Minus 1. So if I put minus 3, it should not have 2 roots. Whoops, sorry. And you see it doesn't, because it doesn't cross the axis here. Let me zoom in a bit. See, that's it there. Now, watch what happens if I put k. What did I say k is not allowed to be? Minus 1, wasn't it? Yeah, if I put k is minus 1, you see what's happened there? Like it's
a line.
It's a line. It's no longer a quadratic. If I draw this, see, there it is there. If k is equal to minus 1, this turns into a line instead of a quadratic, because this piece here will be 0. Okay. Let's do one more. What about if I do a number that's just a little bit bigger than minus 1? So like minus 0.99.
You're doing it for x.
Sorry, thank you, for k. Minus 0.99. Will that have 2 roots or not?
2.
Should still have 2, but just about. Because it's just about bigger than minus 1. Oh, sorry, I put into the wrong one. Yeah, put into this one. K minus 0.99. Okay, there it is there. Now let me clear this, so I'll need to zoom in. Okay, I'll zoom out. Now, okay, it's not as extreme as I thought, but you can see it still has 2 roots. It's just getting closer to the axis here. Let's make it even more extreme. Let's say 3, that's minus 0.9999.
8, 9.
8, 9. More 9s.
All right.
9, 9.
You did the wrong thing.
No, it is. I think I have to.
The series.
Whoa.
Isn't that a 9?
It's so flat, it looks like a line. I think I really have to zoom out. Ah, there we go. Yeah. Now think about that. What value of k makes it a flat line?
Minus 1.
Minus 1. And it was nearly minus 1. So look, it was so flat that I have to zoom out to minus 20,000 so I can see the curved shape. Yeah? This is more just to expand your mind, which I think is expanded enough now. Okay, so I'll give you a little break in a moment, but just the questions you need to do. Okay, look. So for number one, yeah. Well, I'll leave it here for your copy. So number one is quite short, so you can do V, W, X, Y, Z. It's very, very short, so it'll only take you like 2 minutes. Number two.
Is it X, Y, Z?
No, I want one that has 2 brackets in it as well. So
D and X.
N.
yeah, no, I see like IJK. IJK. And then also from number 3, I want an example of 2, 1, and 0. So W, X, and Z. Hey, you'll have your break in a few minutes. I want you starting on this for 5 minutes, and then you can take a break.
We will have any equations where Z we'll get like, I don't know, 2 answers, for example, X equals to -1 and X equals to 5. And we'll have to draw the line and find out.
Yep, we'll do that. That's actually later in this chapter, possibly. Where is it? Page. Ah, there it is. Page 40. Hang on. I want you working, Mohammed Sultan. Not chatting, working. Get working. Yes, you need the book, don't you?